Hello everyone, welcome to Unprocessed Math. In this lecture, I will talk about definite intervals. So let's quickly get started by looking at the definition of a definite integral. So the definite integral of a function f over an interval ab is defined to be the total signed area between the points x equals a, x equals b, and under the graph of this function. And in this definition, signed area means that if a region lies above x-axis, then it will have positive area, and if it lies below x-axis, then it will have a negative area. So let's see that with looking at this simple example. So suppose the function f is given, and this so it has the graph of the function f is given by this pink curve. So in the first part, we want to find the definite integral of this function between -2 and 1. So it's going to be the area that lies between -2 and 1 and under the graph of this function, or between the graph of this function x-axis. So that region, the region that lies between x equals -2, x equals 1, x-axis, and the graph of this function is going to be this shaded, this green shaded region. So it's going to be the area of that region. And since this region lies above x-axis, so it's going to have a positive area. So as you see here, I have a triangle here. The length of this side is 3. The height of this triangle is 2. So the area of the green triangle that you see there is 3 times 2 divided by 2. So here I'm simply using the area formula you had for a triangle. And that simplifies to 3. And it's a positive number because this green region lies above x-axis. So the definite integral of this function between -2 and 1 is equal to 3. Now let's look at the second example here. Here I want to find the definite integral of the same function between 1 and 2. So it's going to be the area that lies between 1 and 2 and between the graph of this function and x-axis. So it's going to be this region here that's shaded. That's the red shaded region. So again, what I see here is a triangle. The length of this slide is 1 and the height is 2. So the area of this triangle is going to be 1 times 2 divided by 2 using the area formula you have for a triangle. But since this region lies below x-axis, it's going to have a negative area. So that's why I'm putting the minus sign here, because it lies under x-axis. If you simplify this, you get -1. So the definite integral of this function between 1 and 2, and this is the notation that is used, is just equal to -1. Let's look at another example. So here, again, the graph of this function f is given by this pink curve, and we are asked to find the interval, the definite integral from -2 to 2 of this function. Okay, but you see that between -2 and 2, this function changes sign, meaning that in one part, it's above x-axis, which is here, and in this part between 1 and 2, it goes below x-axis, because it's basically the same example we saw earlier. But here I want to find the definite integral from -2 to 2, and because in curved, so in this case I have to break this definite integral into 2 pieces, because you see between -2 and 2. I have a positive area because the graph lies above x-axis, and between 1 and 2, so you see the graph is under the x-axis, so it's going to give me negative areas. Because of that, I'm going to break this up between -1 and 1 and 1 and 2. So you see, instead of going directly from -2 to 2, I go from -2 to 1 and then from 1 to 2. So I'm covering the whole N2. So this is going to be the definite integral from -2 to 1. It's going to be we saw this earlier today, that it's going to be the area of this green region, which is 3 times 2 divided by 2. That's going to be the definite integral from -1 to 2. And then the definite integral from 1 to 2, in this case, the area will be negative. So it's going to be the area of this triangle here. So the area of the green region is going to be 3 times 2 divided by 2. The area of the red region is going to be negative 2 times 1 divided by 2. And if you simplify this, you will get the number 2. So the definite integral of this function from -2 to 2 is equal to 2. And that's because the sum of the areas of these green triangle and the area of this red triangle, but that has a negative area. So if you just add these numbers, you're going to get 2. So let's look at another example. In this example, I want to find the definite integral of this function f. Again, the curve is given by this pink curve. So it's the definite integral between -2 and 3. So you see between -2 and 3, the function goes above and below x-axis, several times. So this is going to be so you are going to go between -2 and 3, and you see that you can break it up into 3 pieces. So it's from -2 to 1, and then from 1 to 2, and then from 2 to 3. So between -2 to 1, the area is going to be negative 32. So these numbers that are written here shows you the area of that region. But because this region lies under x-axis, so in calculating the definite integral, it's going to be -32. Then I have this region. It's going to be +12 because it's above x-axis. This one is also going to be +18 because it's above x-axis. And if you add all of these numbers, it's going to be -2. So the definite integral of this function f from -2 to 3 is equal to -2. Let's give the next example. So here we want to compute the definite integral from -2 to 2 of square root of 4 minus x squared. So square root of 4 minus x squared is actually the graph of a half circle between -2 and 2. So it's the graph of a circle of radius 2 above x-axis. So the definite integral from -2 to 2 of this function is just going to be the area that lies between -2 to 2 and between the graph of this function and x-axis. So it's going to be that green region that I have shaded there. So all we need to do is just to find the area of that green region. But that's just half the area of a gist of radius 2. So you just use, so it's going to be 1/2 because this is just 1/2 of the area of a disk. And then the area of a circle or a disk of radius 2 is just pi r squared. But in this case, r is equal to 2. So you get pi 2 squared, and you divide by 1/2 because you'll only have half of the area of a circle, and you simplify that, and you get 2 pi. Let's look at the next example. So here I'm given the graph of the function y equals -2x plus 4. That's just, this is just a straight line that I have graphed there. And in the first part, I'm going to evaluate the integral from 0 to 2 of this function -2x plus 4. Okay, so let's look at this region that lies between 0 and 2. So this is 0, that's 2. So it's going to be the area that lies between 0 and 2 and between the graph of this function and x-axis. So it's going to be this region here. So all I need to do is just to find the area of that triangle. So and it's going to be a positive number because this region lies the ball x-axis. So all you need to do is just to compute the area of that triangle, which is 4 times 2 divided by 2. So I get 4. So the definite integral between 0 and 2 is 4. So let's look at the definite integral between 0 and 3. So between 0 and 3, so you see in one part, the graph is the ball x-axis, in the other part, the graph is under x-axis, so I have to break it up into 2 pieces. So you see between 0 and 3, I have to divide it into 2 pieces. One piece is going to be this that we already did, and the other piece is going to be the area between 2 and 3. But the area between 2 and 3 will be negative because it goes under x-axis. So the definite integral from 0 to 3 of this function is going to be definite integral from 0 to 2 and then from 2 to 3. From 0 to 2 is going to be the area of that triangle, which is just 2 times 4 divided by 2. We did it in the first part. And then minus the area of this region. So it's minus, we get this minus sign because the area is under x-axis. And then you find the area of this triangle. This side is 1, this side is 2. You know, the coordinates of this point is 3 and minus 2. So the y coordinate is minus 2, meaning that this distance is 2. This distance is 1. So it is 1 times 2 divided by 2. I'm using the area formula for a triangle. And if you just simplify that, you will get 3. In the last part here, I have the same function, but I want to compute the definite integral between 0 and 4. So it's all the way from 0 to 4. And you see that between 0 and 4, between 0 and 2, the area is above x-axis, and between 2 and 4, the area is under x-axis. So because of that, I will again break this up into 2 parts. The first part is integral from 0 to 2. It's the area of this triangle. We had done it before. It's the same. It's 2 times 4 divided by 2. And it has a positive sign because it's above x-axis. And again, between 2 and 4, I will give a negative sign because the area is under x-axis. And this side is 2. This side is 4 because you see the coordinates of this paint point is 4 and minus 4. So it means that the y coordinate is minus 4. That means that this length is 4. This length is 2. So you have 2 times 4 divided by 2. And you simplify it and you get 0. So the definite integral of this function minus 2x plus 4, the thing 0 and 4 is actually equal to 0 because the sum of the areas of this and this, which is a negative number, adds up to 0. So let's look at another example. This time again, I'm given this function y equals fx. The graph of that is this pink curve that I'm given here. And I want to compute the definite integral between 0 and 5. So I want to go all the way from 0 to 5. And you see, if you want to compute the areas, so what I'm going to do is, I'm going to break it up into 3 pieces so that I can compute the areas much more easy. So you want to go between 0 and 5. So what I do is that I see that if I go up to 0, up to 2, then here the area is going to be just a rectangle or a square. So I go from 0 to 2, and then between 2 to 3, I will get that yellow region. And between 3 to 5, I will get that green region. Okay, so the definite integral between 0 and 5, it can be written as the definite integral of the same function from 0 to 2. That's what I have here. And then from 2 to 3, and then from 3 to 5. Okay, so the definite integral between 0 to 2 is going to be the area of that red region. So this side is 2, this side is 2, so you have a square there. So you have 2 times 2, that's going to be the area of the red region, but you know that you have to put this minus sign because the area lies under x-axis. So the definite integral between 0 and 2 is going to be minus 4. Then the definite integral between 2 and 3 is going to be the area of this yellow region. This side is 1, this side is 2. So you get 2 times 1 divided by 2, but you need to put this minus sign because the area is under x-axis. Next, I move on to computing the definite integral from 3 to 5. From 3 to 5, it's going to be the area of that 3 region. This side is 2, so you see I have 5 and 3, so 5 minus 3 is 2. So this side is 2. This side is also 2. That's the same as the height of that plug. So the area is going to be 2 times 2 divided by 2. But you see, I don't have a negative sign here. It's a positive area because this gray region lies the bar x-axis. And if you just add up all these numbers, you will get minus 3. That's the definite interval of the function f from 0 to 5. And so if you understand these examples that I showed you, that's pretty much it. That's pretty much it. And so that's what definite integrals means. So it's all about computing these signed areas between the graph of the function and the x-axis between those two given numbers. And this the definite integrals have some basic properties. So the definite integral of any function, if you go just from a to a, they must then be equal to 0 if you have the same numbers there. The definite integral from a to b and then from b to c is the same as going from a to c. So because you see these two numbers are the same. So you go from a to b and then b to c, so that will add up to the area from a to c. That's what you have in the right-hand side. We have already saw this. We have already seen this in the examples that we saw earlier. So if you switch the lower bound and upper bound of integral, the definite integrals, then you will get the negative side. So integral from a to b is actually equal to negative integral from b to a. So this tells you that the order of the upper bound and lower bound are actually important. Integral from a to b is different from integral from b to a, and the difference is just a negative sign. Then, if you integrate f plus g from a to b, you can just integrate f plus integral of g. So this means that the definite integral of sum of two functions is sum of the definite integrals, and the same is true for the subtrahend function. So the definite integral of the difference is difference of the definite integrals. And then if you have a constant in a definite integral, you can actually put the constant outside. So these are the properties of definite integrals. And if you need additional practice, you can take a look at the problems in section 5.2 of the Apex Calculus Tool textbook. And for additional help that you may need, visit mathematicians.com. I'll put the link for both these resources in the description.